Today we're going to show you how to quickly stand up a CoreOS cluster using CloudFormation, install the StackEngine controller as a container on CoreOS, and then manage a mesh with a few containers and images. Let's get started. As you can see, CoreOS provides a simple way to launch one of their clusters. However, before we go about doing that, we need to visit discovery.etcd.io/new. This is a global discovery service that CoreOS provides that helps sew together their machines into a cluster. I'm going to copy this information as the CloudFormation template will use it in a little bit. Going back to the CoreOS page, I'm scrolling down and launching in US East. I'll keep the name of the stack. We can see that CoreOS provides the template name for us. We can also see that they've opened a new tab connected to StackEngine's AWS account. I'll place the discovery URL that I copied a moment ago into the right box. Our key pair name is StackEngine East. This is the same key pair you would use to launch any AWS machine. Click Next. I have no need to add any extras. I can review the information, and now CloudFormation is going to go out and create a new set of machines for us. We can see that the cluster is now being created. Our next step is going to be to install the StackEngine controller via the command line. Once the CloudFormation stack has been started, we'll need some address information for each of the machines. I've created a simple file that's handy in the command line. To start a StackEngine container, the first thing we're going to need to do is to sign into a machine. So now I'm into the machine that I intend to be the leader. So from the StackEngine documentation, you'll find a section on installing the controller as a container on CoreOS. The first thing to do, in our case, is just to make a simple workspace. Remember that in CoreOS, most of the file system is read-only. Therefore, you'll need to do this inside the workspace of your user. The next thing I'm going to do is I'm going to go and get the Docker file. We'll take a peek in there. Finally, the last command will build the image. We'll wait a few moments while the layers are pulled. We're using BusyBox as our base, so it's not like we're trying to pull 400 megabytes of Ubuntu. It's pretty darn quick. All right, so we're ready to run the StackEngine controller in a container. Again, in the documentation, you'll find this command. Right now, what we have is Docker is running something. It's running it with a host name of Stacky001. It's publishing a few ports. 8000 is where the UI is found. The other two are for Raft, Gossip, and our remote procedure call communication. The name of the container is going to be StackEngine controller if I want to manipulate it. And finally, we're mounting the sockets so that we have control of the Docker process itself. The actual magic of starting the controller is in the last line. What's important here is we need to bind the controller to its interface so that when the machine, its host, catches traffic, it knows that it should go to that container. The container is started. We'll trust but verify. We can see that the container is in fact actually running. So we'll stop here for a moment, go and get our browser, and show that that's actually happened. By visiting the public IP address on the leader machine at port 8000, we end up being redirected to a page where we need to create a user account. So, to do so, just fill out the form. And now we can see that we have a total of one container, one host, a total of one host, a total of one container, and 17 images. What's interesting is, of course, we have a container, and that container is the one we started, the StackEngine controller. Looking at images really quick, let's just take a quick look at the controller. Maybe look at the graph. And we can see that there's quite a bit going on there. We'll get into more of that a little bit later. But for now, we've convinced ourselves that the application is in fact working. To start a follower in the StackEngine mesh, we need to log in to the next machine in the list. You can see that we are, in fact, there at this point. I have already downloaded and built the StackEngine image on this machine, as it's an identical process to the one we did on the leader. What is, however, different is how to run a follower. Just enough so that we'll take again and we'll copy out of the documentation the actual command. Notice nothing about how we set up Docker is changed. However, when we go to run StackEngine, again, we want to see the admin up. That way, if the leader fails, a follower can support the UI as well. We're going to run our log at debug level. The bind address, again, is the interface on which the StackEngine controller will be receiving traffic on this machine. So it is the private interface of the machine we are on. Join tells the controller to join the mesh as a follower. Again, this address is pointing to the leader because the follower needs to know whom it is to follow. Starting the controller, we should now check to make sure that it is in fact running. It is, a little trust but verify there. And we will now switch over and check the UI to see if the new machine and its new container have been recognized by the mesh. Behind the scenes, I in fact started 2 followers to the leader. So as you can see now, we have 3 running hosts. Looking at the details, we have 3 StackEngine controllers running. So let's make it a bit more interesting by starting a Redis container. Typically, I would have to go and create a component that represents the Docker public hub. However, we include that by default. So I'm going to leverage that and say that I'd like this to be the Redis base component. It's coming from the Docker public registry. And I'm going to go get Redis latest and save it. Now I want to run that Docker component. We'll call this Redis example. We'll put this on 2 of our hosts. Well, let's choose the 2 followers. And in fact, we'll run 2 Redis containers on each host. We're not going to do anything with the host, but in the advanced options, we'll let these run in privileged mode, and we'll leave the container host names alone for now. Clicking go. What's happening in the background is each machine has been told by the leader, hey, go and get the Redis container from the Docker public hub. Once those are downloaded, just as you would see on the command line, image by image, the containers will be launched, named accordingly, and we will see them come up in the container screen. We'll simply need to wait for a moment while all that's happening in the background. So if we were to go over to the container page at this point, we will see that each of the 2 followers, 010 and 020, have two Redis example containers now running on them. It's pretty easy to understand that you could create your own private registry component and pull the images for your intellectual property, your application, yourself, across in the same way that we have done Redis. But once things are running, what can you do? Well, let's look at the details of this particular container. We can see here that we can stop and pause, and if in fact we pause it, we can unpause it. We have a plethora of information about the various aspects of the container that are running. Nothing here should be of any great surprise. And we can now see the container is in a paused state. Start it back up again. I'm not going to wait for that to complete. I'm going to go back to the container page. Oh, well, it already has completed. Let's take a look at some of the images that we have. For the StackEngine image, we can see a history starting with the familiar BusyBox layers and moving along until we get to the entry point of the actual container from the Docker file that we saw earlier. We can see a graph of the system the various layers and the relative sizes. We can see what hosts this particular container lives on. Notice that it's only on one machine because we gave it a host name. And we can see what containers are derived from this image. Additionally, we can tag this image and see that appear in the image tile. We can remove the tag. We have a moment to undo that. Or we could push the tag to our private repo. Additionally, we can remove this particular machine altogether. We could start another from it, although that wouldn't be such a great idea to have two controllers running on a single machine. And of course, as you saw, we can tag the image. If we'd like to know more about the host, we can click going from there and see that there are 3 running containers on that host, as we expected, the StackEngine controller and 2 Redises. In summary, a great deal of new functionality has been added around the management of images, the identification and management of containers, and the ability for you to see your infrastructure at a glance. We hope that you'll take the time to sign up at stackengine.com. Thank you for your time and your interest.